Hi everyone, welcome to the channel. I hope each and one of you is having a wonderful day. Today we'll be looking at this problem called edit distance, and we're given two words, word 1 and word 2, and we want to find the minimum number of operations required to convert word 1 to word 2. And here are three operations we can perform on a word. We can insert a character, delete a character, or replace a character. So here we see an example of horse in ROS, and the output is 3 because we replace H with R and we remove R, so remove this R, so now it's R rows, and then remove E, and then the final two words will be the same. When we look at intention and execution, we see, alright, this E and I do not match. Well, I guess they start with T first, so they remove the T, replace the E with I, so then they have this. Well, replace N with X here, and replace M with C. So basically it's a very similar example to this. And the way we can solve this problem is we can make a DP matrix. And here's an example. Let's take this example 1 to make the DP matrix. And so here we have R, S, E. We'll keep 0, 0, meaning none of the characters are used. We have R, O, S. So this is our DP matrix. Whenever we do DP or dynamic programming, we want to have a recurrence relation. So DP of I, J, I is the row, J is the column, indicates cost, number of operations. Now to initialize our matrix, the 0, 0 position would have 0 because, well, I should explain why J are. So I means the first word, index 0 up to I, and word 2, index 0 up to J. So an example is if DP 0, 0 means word 1, which is horse, we have 0 characters. Which means we just have an empty string. And word 2 is also an empty string. However, if we had DP of 1, 0, means word 1 would be H, and word 2 would be an empty string. And so when we fill this out, we know that for this case, 1, 0, the answer is 1 because there should be a space there. Yeah, the answer is 1 because the first word has H and the second word has nothing, so we have to do insert word. And so if we continue this trend with 0 characters in word 2, and then for word 1, we have 2 letters, so on and so forth, right? So we would always have to fill this up to initialize the matrix. And similarly with the first column, first row, it means that this word, we use 0 characters, so to match up with R, we have to insert an R. And then for this RO, we have 2 characters, but word 1, we have 0. And similarly, this is how we initialize our matrix. Once we have the initialized matrix, we have a couple of cases. Our cases are when 2 letters, ith and jth position, match. So we take an example where the two match, like HO and RO. So we see that the two O's match. So if we see, without looking at the matrix, we take an example, we look HO, RO. So we see that the solution to this equals 1. And we looked at also when we have H and R, this equals 1, so it means that dp of 2, 2 equals dp of 1, 1. And this makes sense because anytime you have two matching letters in the ith and jth position, it means that adding these two characters will not incur another additional operation to form this word. So that's why you can subtract I minus 1 and j minus 1, meaning if you had not added these two letters, what was the previous cost? So whenever you have a match, you do dpi minus 1 and j minus 1. When no match, well, I guess we could just write else. We want to find the minimum number operation, so we'll minimum all the possibilities. And it says that we can insert or delete a character. So one thing about this problem is when we have insert or delete a character, insert to word 1 is the same thing as delete from word 2. An example could be R and HO. If we are inserting a word for word 1, then word 1 will have one letter greater than word 2. So that's why it's j minus 1. So the second word has one less letter. However, if we delete one letter from word 2, it's also j minus 1. And the current word 1 will have one more letter. So that's why these two are equivalent statements. However, another case that we can have is insert to word 2 or delete from word 1. And in this case, we have dpij as usual. And it would be dp because we're inserting to word 2. Now the second word will have more letters. Similarly, if we delete from word 1, it would be I minus 1 since that's the first word, and j is the second word. So one thing to keep in mind is when we delete a word, it costs operation, so we need to do the plus 1. So when we minimize, we will have dpi j minus 1 plus 1 and dp I minus 1 j plus 1. Another case is remove word. So when we remove, or not remove, sorry, I mean replace, and in this one it says delete, insert, yeah, so that's great. So replacing a letter, it will be j equals dp I minus 1 j minus 1 because the current letter, if we replace it, it will automatically be a match. So we do plus 1 because we're performing the operation, and we add on to however many minimum operations it costs before we added these two letters. So that's why letters for each of the words. That's why it's I minus 1 and j minus 1. So that'll be our third case. So as we see HRS, E, and ROS, we can continue filling out this matrix doing row by row, starting from the top row. So once we see HR, we compare, we see H and R are different. So then we have the case where we don't match. And so we look at 0. Well, this is the 1, 1 position. So we look at 1, 0, and we see there's a 1. So we add 1, which will become 2. And then this one becomes 0, 1. And we see in 0, 1, it's 1, so we get 2. And this one is 1, 0, so that's 1 right here, and plus 1, which is 0, or which is 2. And then I minus 1, j minus 1, which is 0, and we do plus 1, which is 1. So you see for HR, our minimum is 1. And then we go to H compared to RO, and we see H and O do not match. So checking quickly, we know that we're checking this position, and this position. So move things a little bit faster, we see that would be 1. So the minimum would be 1, so we add 1, which would become 2. And then for 3, the minimum from this point, 1, 3, is 2. So we add 1 and we get 3. So looking at this checking, we see H compared to ROS, the minimum is 3, which makes sense because we have to replace the H with the R, and then we insert 2 letters, O and S. Now we have O, and then the minimum we see is 1. So we add 1, then we get 2. We look, check these two, bam, bam, bam. So minimum is 1, so now we get 2. Then we check, now we're on this position, and we check these 3, the minimum is 2, so now we get 3. So checking HOROS, we see that the O matches up, but we need to place H and R, and we need to add S. So that's why we have 3 right here. The last thing we see R, and R, it is a match. So when we have match, we take this top corner. So we have 2. And then when we have R and O, there's no match, so we have to check these 3. They're all 2, add 1, which is 3. And then R and S, they don't match. The minimum is 2, so we add 1, now it's 3. So HRO compared to ROS, the O matches, and H and R need to be replaced. So it looks like this answer is incorrect. Let me see where I could have made a mistake. So here R matches, so we don't add 1. We get 2. HOR and R cost 2 because you need to add H and you need to add O. Then when we get here, also does not match, so we check those 3 and then we add 1. HO. Yeah, let me see. This one, RO and HOR definitely should not be 3. RO is 3. Oh, sorry, I forgot to put +1 here. Oh, actually, when I replace a word, yeah, why does replacing a word not incur +1? No, replacing a word should incur +1, so yeah, that +1 is necessary. So could it mean that I meant, oh, actually, HO and RO should be 1. Right, because this one is a match, so that's 1. Now I found the mistake. So here we get 2. HOR and RO is 3. Because H and R, you have to replace. Well, that one should be 2 as well. This position makes sense. Oh, right. And this one doesn't match, so that's why it becomes 2. HO and ROS is 2. Yes, because you have to replace HR and then add S. RO and HOR. Yeah, that one is 3 because H is matched up with R, so you have to replace O matches and then add R. Oh, shoot, this one should be 2. Oh, right, because the top is 1, so it is 2. HOR and, yeah, this one is 3 for sure. Okay, so I think that looks good now. We move on to HRS. We see S and R do not match. The minimum is 2, add 1, so it's 3. And then we check O and S do not match, so then we check these three positions and we see the minimum is 2, so we add 1, which is 3. And then S matches up, so we take this position and we inherit it, so now it's 2. So HRS and ROS. We have to replace H with R and then delete R. So then it would match up. So 2 looks correct. And now we're in this position. E and R do not match, so we take the minimum, these three positions, and then we add 1. So it's 4. And then O and E, they don't match, and we take the minimum position of these three, and we add 1, which is 4. And then S does not match up with E. Take the minimum of these three and add 1, which is 3. So if we wanted DP of 1, 2, 3, 4, 5, and DP 3, DP length of word 1, length of word 2, is 3. And we see that is the answer for this one. So looks like our answer works for our first example. And this is a pretty generic example, so we don't have to run it through as well. So now we are ready to code things up. So I want to make the DP matrix. And before we make the DP matrix, we need to get the length of the first word and the second word, so we'll call it length A. Now to make the matrix, we'll call it DP. And the number of rows is equal to the first word and the number of columns is equal to the second word. So okay, and then once that happens, we have our DP matrix, and then we have to initialize our DP matrix, making the first row and first column. First row 0, 1, 2, 3, and then first column 0 through 5. Go through length A plus 1. Do this because 0, 0 represents no characters from either word. Doing this for the rows. And DPI. The row changes, the column remains the same. Now we do the first row. So row stays the same and the column changes. All right. Once we do that, we fill up the matrix. This example we showed, so we don't need this anymore. These are also explanations. Now we have the two cases. Bam. Let's use these now. So for I in range, we start from 1 because 0, 0 is it will just remain 0. Same with the columns. This is why we start with length of, we start with 1 and go up to length of b plus 1. Now we said the cases where if the two letters are the same, so if go into the word I minus 1, close the word j minus 1. 1, word 2. The two letters are the same, then we inherit, so dpi plus dp of I minus 1, j minus 1. And then our else case, we basically already have encoded out right here. We have the two cases for inserting first word, deleting the second word, or inserting the second word and deleting the first word. I see in the end, we return dp length of word 1, so it's basically len A, len B, to return this bottom corner. 0 to 5, 3, yes. Let's look through the code quickly, make sure things are good. So we see word 1, word 2, bam, bam, word 1, word 2, we get the length A, length B. Initialize the matrix, make sure we have the columns, length B plus 1. So it goes up to length B, and then number of rows up to the first word, plus 1. And then we initialize the DP matrix, first doing the first column, using the first word to determine how many rows we need, and then we do the first row, indicating how many columns we need, using the second word's length. And we go through, we fill in the matrix starting from the 1, 1 position, filling out every row starting from the first row. And then if the two letters match, then we will inherit the number of minimum operations for the next word. Else, we have the insert and delete cases. Okay, let's run the code, see if this works. All right, that looks good. Okay, awesome. So it looks like it's submitted. And so now we could talk about runtime. So for this algorithm, well, because we made the DP matrix, we can talk about space complexity as well. Space complexity m by, or m letters in word 1 and n letters in word 2. That's our definition for the input. And so for space, because we make the matrix, we will have O of m n. Space complexity. That's our DP matrix. Now for time, we initialize the DP matrix, so we do first column and first row. So time complexity m plus n. That's us initializing the DP matrix. Then we fill up the matrix starting from 1, 1. So that's plus m times n. And in big O notation, we take the highest order. So this will be, in big O notation, m times n. And that's it for this problem. So thank you everyone for watching. I hope you guys learned something and had as much fun as I did. If you would like more content, please like, subscribe, and share with anyone that will be interested. And follow me on social media. Thank you for your time.